early 2026, 4 humans will leave Earth. Not to land on the moon, but to answer a question NASA has been avoiding for more than 50 years. Are humans actually ready to return to deep space? Artemis II will be the first crewed mission to travel beyond Earth's protective shield since Apollo. No space station nearby, no rescue mission waiting, no quick way home. This flight isn't about planting flags or delivering historic images for the news cycle. It's about discovering what quietly breaks when humans leave Earth again, before NASA commits to doing it permanently. On paper, Artemis II looks like a cautious mission. There's no lunar landing, no surface operations, no risky descent engines or touchdown sequence, just a flyby. But that apparent simplicity is misleading. Artemis II removes the safety net that has protected human space flight for decades. Low Earth orbit missions always have backups. The International Space Station is close. Rescue spacecraft exist. Abort options are realistic. Once Orion leaves Earth on Artemis II, none of that applies. The crew will be farther from home than any human since Apollo 17. Communications will be delayed. Decisions will have consequences that can't be reversed quickly. Space doesn't need a dramatic explosion to become dangerous. It only needs one small system to degrade slowly, quietly, and persistently. NASA already flew Artemis I. The rocket launched successfully. The capsule survived deep space. The mission returned safely to Earth. From the outside, it looked like the hardest part was over. But Artemis I tested machines, not people. Hardware doesn't experience fear. It doesn't get tired. It doesn't make judgment calls under stress. Humans do. Artemis II exists because history has shown the most advanced systems often fail at the human interface. Controls that look perfect on paper behave differently after days of fatigue. Procedures written for calm conditions break down when time pressure increases. Artemis I proved the spacecraft could survive space. Artemis II must prove that humans can live inside it when space stops feeling distant and starts feeling personal. This mission is not about reaching the moon. It's about exposure. For the first time in decades, humans will experience deep space not as a brief transition, but as a constant condition. Every hour adds data. Every decision is observed. Every minor discomfort is measured. NASA is watching how the crew adapts to isolation, how they manage limited resources, how they respond when small inconveniences stack into real stress. Because future missions won't last 10 days. They'll last months. And before NASA sends humans to live on the moon or attempt the long journey to Mars, they need to know where the real limits are. Not in simulations, not in training, but in flight. If you're interested in how these missions quietly shape the future of space exploration, this is exactly what kind of story we focus on here. Artemis II will follow a free return trajectory. In simple terms, that means gravity alone will guide Orion back to Earth, even if its engines fail. It sounds comforting, but that safety comes at a cost. Once the spacecraft commits to that path, flexibility disappears. There's no stopping, no easy course correction, no chance to wait and see. This same type of trajectory saved the Apollo 13 astronauts, but it also trapped them in a situation where every solution had to work for the first time. NASA isn't choosing this flight path because it's easy. They're choosing it because it exposes how limited human control becomes once gravity takes over, and how prepared crews must be when improvisation is the only option left. Inside Orion, life is simple. There is no excess space, no luxury, no room for avoidance. 4 people will share a confined volume for 10 days. Every task is scheduled. Every movement is deliberate. Eating becomes functional, not comforting. Sleeping happens in short cycles. Exercise is mandatory, just to slow muscle and bone loss. Even privacy disappears. These details are not trivial. They are stress multipliers. Because when something unexpected happens, the spacecraft doesn't react emotionally. Humans do. Artemis II is now testing how strong Orion is. It is testing how humans function when the environment stops feeling forgiving. Beyond Earth's magnetic field, radiation is constant. It doesn't announce itself. It doesn't cause immediate pain. It accumulates quietly. Solar particles, cosmic rays, energy that passes through the human body without warning. Orion includes a radiation shelter, a small protected area designed to reduce exposure during intense solar events. Artemis II will test how effective that protection really is, with humans living through the experience. This isn't theoretical modeling, it's real exposure. Future missions will last far longer than 10 days, and NASA needs the real data before committing humans to deep space for months at a time. If you're finding yourself thinking differently about what long-duration space flight really involves, that curiosity is exactly what missions like Artemis II are meant to challenge. Artemis II is a checkpoint, not a destination. If it succeeds, it unlocks everything that follows: lunar gateway, surface missions, extended stays beyond Earth. If it struggles, timelines stretch, budgets tighten, confidence fades. Mars moves further away. This mission determines whether humans can operate beyond Earth as a permanent condition, not just as visitors. That decision will shape the next several decades of exploration. The Artemis II crew was chosen deliberately. Each astronaut brings experience under pressure. Experience making decisions when systems behave unpredictably. Experience working in isolation. This mission is not about heroism. It's about reality. NASA needs to know how trained professionals respond when procedures meet reality. Because future crews will depend on what Artemis II reveals, whether the results are reassuring or uncomfortable. There is no dramatic countdown attached to Artemis II's importance. Its success will be measured in subtleties. Systems that work without drawing attention, minor issues that reveal larger vulnerabilities, human behavior under sustained pressure. Artemis II is not designed to prove that space is safe. It is designed to show whether space is manageable. And that distinction matters. For decades, humans stayed close to Earth, not because we lacked ambition, but because space punishes assumptions. Artemis II asks a simple question with enormous consequences. Have we learned enough to leave again without repeating the mistakes of the past? If the answer is yes, the next era of human exploration begins? If the answer is no, Artemis II may be the mission that finally tells us why. If you want to follow how missions like this quietly shape the future of human spaceflight, you're always welcome to stay for what comes next.